Good evening, students, class 9th. So today is 25th of July 2020 and we are going to record a lecture for force and laws of motion. Force and laws of motion. I hope that you have watched out the first part of this chapter which we already have recorded yesterday. So force and laws of motion, we are going to continue from the topic which we already have covered just after that. So first law of motion I have already explained in my first video, but let us discuss it once again. So first law of motion is also known as law of inertia. First law of motion is also known as law of inertia. What is the meaning of inertia? So inertia is meant by that if a body is in rest, it want to remain in rest. If a body is in motion, it want to remain in motion until and unless any unbalanced external force is being applied on it. So if a body is in rest, it want to remain in rest. If a body is in motion, it want to remain in motion. It want to remain in motion until any unbalanced external force, is being applied on it. So students, this is first law of motion. If a body is in rest, it want to remain in rest. If a body is in motion, it want to remain in motion until any unbalanced external force is applied to it. The meaning is, suppose an object is here in position A. Will this object move? This is in position A, this object, this block. Will this object move? This block will move? No, it can't move until we will apply any force. So this is first law of motion, also known as law of inertia. So how many laws of motion are there? 3 laws of motion are there. And now we are going to study second law of motion. So students, for understanding second law of motion, before starting second law of motion, it is much more required to understand one more fact related to this, one more term related to this, and that is momentum. Maybe you are familiar with this word, so I will make you more familiar with this word. Okay, momentum. So there are so many definitions of momentum, we will come to that. But before that, let us introduce a very easy definition for momentum. Momentum is defined as the effort of force. You might have noticed, you might have observed that before playing a bigger shot, the player creates the position, the batsman creates the position. Before playing a bigger shot, you must have observed this, that planning like this. His bat is coming like this, and before playing a shot, he just make it sure that his stance is very clear, his bat is in the proper position. Even if any batsman or any bowler, even before bowling a ball, have you noticed that he just take proper run up and then he bowls? Once he bowls, after taking the run up, you find that the speed is very high. That's why a fast bowler always takes the run up. What will held out if he will not take the run up? Will he able to apply this much amount of velocity, this much amount of force? Fast bowlers, any fast bowler is able to bowl at least 140 km/h. How this is possible? Because he is taking the stance, he is providing the effort, and when he provide the effort of force, he is able to deliver this much amount of force. Okay, and you have noticed that a spinner while bowling, he do not provide this much amount of effort. That's why his ball is very slower one. Once the batsman even playing a powerful shot, firstly create the effort, like bat, he is swinging the bat, Once he is swinging the bat, and when the ball connects to it, it creates a very big impact. Yes or no? So momentum can be defined as the effort of force. How we will calculate the momentum? Okay, that's true. That's, we can understand it, that it is the effort of force. That's clear. Now my effort of force, my momentum will decide that how much force I will produce. If a batsman is providing a greater effort of force, he is, before playing a lofting shot, he is just preparing himself, so he provides a very greater amount of momentum, and that's why he is able to provide a greater amount of force. Now in the similar way, okay, that's correct, momentum is defined as the effort of force. But how to define it mathematically? In physics, that is clear. So mathematically, momentum is defined as the product of mass and velocity. Momentum is defined as the product of mass and velocity. It is denoted by P. By alphabet P we will denote it, and P, as I already have said, this is the product of mass and velocity. So P is equal to m into velocity v. Suppose an object is moving with velocity v. So m is the mass. Here m is the mass of object, v is velocity. Now which kind of physical quantity will be the momentum? Is it vector or scalar? So momentum is depending on velocity. Velocity is vector or scalar? Velocity is vector. So if velocity is vector, momentum is going to be vector. It is a vector physical quantity. It is a vector quantity because it requires magnitude as well as direction. Now remember one thing. Now what will be the unit of momentum? Unit. So unit will be mass. Mass is kilogram. Velocity meter per second. So unit will be kg meter per second, or kg ms minus 1. That's the unit for momentum. Kilogram meter per second. This is the unit of momentum. Now we will try to understand the effect of momentum. Have you noticed, suppose we are traveling to a hilly area like Haridwar, suppose. So you will find that there is a place on the way of Haridwar, name is Chidyapur. So you will find near Chidyapur, or once we are near Haridwar or any hill station, you will find it is written, just be careful with the stones, big stones or rocks, piece of rocks. Why it is written? Sometime when I was student, or I was of your age, so I used to think that we are having a car and we are in the car or in a bus and our mass is very greater. Okay, so what effect can a piece of stone can produce? Why should we worry for that? But the reason is, now try to understand it, that stone is coming from a very high height. Okay, the height is already high, so, and it is having a mass as well. Piece of stone is having mass and it is coming from a very greater height. So once it will keep on rolling down, try to understand, it is, the piece of stone is keep on rolling down. Suppose the mass is 20 kg. What is the initial velocity? 0. Initially the velocity is 0. Okay, initial velocity is 0. It is coming down, down, down. So its velocity is increasing or not? Its velocity is increasing. Ultimately it is increasing. So once it will reach to the car, it will have a very high velocity. Yes or no? It will have a very high velocity, and the stone is already having certain amount of mass, say 20 kg. In velocity, suppose once it is carrying to the ground, velocity becomes 100 meter per second. Now how much momentum will be created? 2000. Yes or no? So 2000, a very greater amount of momentum will be created by even a very small piece of stone that was only 20 kg. How this held out? Because it is coming from a very greater height. So momentum will introduce a very greater value if velocity is greater, and it will offer a very lesser value if velocity is lesser. So momentum depends on velocity as well as the mass. So don't be relaxed even with a small body if it could have a very high momentum. So momentum is the product of mass and velocity. Now you may understand that why momentum creates the force. This is the effort of force, momentum, because the momentum is higher, effort of force is higher, so it will produce a very large effect on this car, and it can damage, it can seriously damage it. So I hope you understood the meaning of momentum. It is effort of force, and this is given by the product of mass and velocity. So once an object of certain mass is coming with a high velocity, this will create a very high momentum. You also use it in your daily life. You are not actually aware about this. If you have watched out CID, Daya just open the door. What Daya do? Daya is creating the momentum. Firstly, he is coming in the backward direction and then coming. So what happens by this? By this, he is able to produce more momentum. He is having a greater mass. Already his muscles are having great amount of mass, and he is coming in backward direction and just pulling it. So what will happen? Held out. It will create a very high amount of momentum. Even the bowler, he is coming in backward direction and then bowling. So it will create a very high momentum, and this will result out to be a very high velocity in terms of his bowling speed. So momentum is very, even suppose we are jumping, okay, there is a pit of hole in the road. So what you used to do, we are coming in backward direction and then we are jumping. So once our momentum is higher, effort of force is higher, so we are able to cross it. Why we are coming in backward direction? Because I already have told you that momentum is product of mass and velocity. Mass we already have, and we want to create a very high velocity. That's why we are coming in backward direction. And we already know V is equal to U plus AT. Final velocity will be greater. Why? How it will be greater? If we have acceleration and we are giving time to it. We have acceleration but we are not giving time. What will held out? Final velocity cannot be greater. That's why we are coming in backward direction and we are giving proper time to create a very high velocity. And once the velocity will be higher, momentum will be higher. Is it clear? So momentum should be clear now. So this was required to be explained before starting second law of motion. Second law of motion. Second law of motion. So students, what is second law of motion? The rate of change. The rate, I am writing the statement, then I will explain. The rate of change of momentum, the rate of change of momentum is directly proportional to the applied force. The rate of change of momentum is directly proportional to the applied force. This can be little difficult to understand just by the definition or by the statement which I have written. So let us come to the proper example. Suppose we have a body of mass m. It is stationary or it is moving with initial velocity u. Suppose it is moving with velocity u. Now let us write the case study along with it. So let us consider a mass m moving with velocity u, and after applying a force F for time t, comma, its velocity becomes v. Suppose we have an object of mass m. Initially it is moving with velocity u. Object mass m moving with velocity u, and we applied a certain amount of force. We applied a certain amount of force for time t, and due to this force its velocity will become v. Mass will remain same, velocity will become v. For t time we have applied the force. Now just try to understand this example, what this statement is saying. So what is the initial momentum? According to the case which I have written, what is the initial momentum of body? What is the initial momentum? As I already have explained you in my lecture, that momentum is defined as, what is momentum? Momentum is the product of mass and velocity. What is the mass? M. What is the velocity? U. So what is the initial momentum? Initial momentum will be product of mass and velocity. So mass is m, velocity is u. So initial momentum of the object is m into u, mu. What is the final momentum? What is the final momentum of body? Mass will remain same and velocity is now v. So final momentum of the body is mass into velocity, mv. Now try to correlate this example. What is the change in momentum? What is the change in momentum? Change in momentum is mv minus mu. Yes or no? mv minus mu. Whenever we have to calculate the rate of change of momentum, I have told you so many times in my previous lecture, whenever we are calculating the rate means with respect to time. We are dividing it with respect to time. Yes or no? We are dividing it with respect to time. So rate means mv minus mu upon t. This is the rate of change of momentum. We just define it for a unit time. Means in t time, what is the change in momentum? mv minus mu. So for unit time, what is the change in momentum? mv minus mu upon t. So this is the rate of change of momentum, mv minus mu upon t. This we have calculated. Now let us come back to the definition which we have written. Rate of change of momentum is directly proportional to the applied force. Now consider a car. Consider a car. Car is stationary. Now what will be the change in momentum? The change is depending on the force applied or not. If once you will apply a greater amount of force, the greater momentum will be created. There will be a greater change in momentum. If you will provide a lesser force, lesser change in momentum. So rate of change of momentum is indirectly, definitely depending on applied force. If you will apply a greater force, there will be greater change in momentum. Suppose a small child is trying to push a car, to pull a car. What will have held out? He can create a very less change in momentum. He will apply a very less force. So car will move by little velocity. So there is little change in momentum. Because momentum is mass into velocity. So there is less change in momentum. And suppose a very tall boy known as a Gabru Punjabi, he is applying a force. What will held out? He can apply a very greater force and he can apply a very greater change in momentum. So in fact the change in momentum is directly depending to applied force. So this is what second law of motion is. mv minus mu upon t. This already we have calculated. Rate of change of momentum. What is rate of change of momentum? mv minus mu upon t. This is directly proportional to mv minus mu upon t. This is directly proportional to force applied. Now suppose m we will take common. If m we will consider common, what is there remaining? V minus u upon t, proportional f. If students are not able to see, I can write it somewhere else. So I think that this introduction part all have understood it. So let me write it here. So rate of change of momentum is directly proportional to applied force. What is the rate of change of momentum? mv minus mu upon t, directly proportional to applied force. Is it clear? Now if we consider m common, v minus u upon t, directly proportional to f. Now you are already familiar with v minus u upon t, change in velocity upon time taken. What is it? This is acceleration. So in place of this v minus u upon t, we can write acceleration. So m into a, directly proportional f. Now just reverse it. This will become f proportional ma. Now once you will remove the proportionality sign and you will replace it by equal, a constant will be introduced. This is a rule, you have to understand it. Directly proportional means depending on. Directly proportional means depending on. Means you will increase the force, momentum, change in momentum will also increase. We are not saying this is equal. For example, suppose I am saying your result is directly proportional to your study or number of hours you study. So we cannot say the number of hours you study is equal to your result. It is depending on. So when you will remove this proportionality sign and you will replace it by equal, then a constant will be introduced every time. This constant, suppose we are considering it 1. So one special case we are considering, suppose if k is equal to 1. If k is equal to 1, then f is equal to ma. F is equal to ma. So second law of motion, when we started studying this second law of motion, we started it as the rate of change of momentum is directly proportional to applied force. This is what we studied. Now if we view it once again, we can define it as the force applied on a body is the product of mass and acceleration. The force applied on a body is the product of mass and acceleration. So the force which we are applying on a body is depending on the mass as well as the acceleration attained by it. For example, I have this mass, okay, and I am applying a force to it. How to calculate this force? How much force I have applied? So suppose we are aware about the mass, we are aware about the acceleration, so we can easily calculate the force by just taking the product of both these. What is the unit of force? The unit of force is Newton. 1 Newton is the unit of force. Mass is always in kilogram. Acceleration in meter per second square. So we will define 1 Newton as well. I hope you understood this second law of motion. So I am erasing this and we will discuss the definition of 1 Newton now. How to define 1 Newton. So F is equal to ma. Force is equal to product of mass and acceleration. So I am defining 1 Newton. When the force will be 1 Newton? If the mass is 1 kg and acceleration is 1 meter per second square, then the force will be 1 Newton. So this is how we will define 1 Newton. The force applied on a body is said to be 1 Newton, is said to be 1 Newton if 1 kilogram, what is the mass of this object? 1 kilogram. If 1 kilogram of mass, what is the acceleration? 1 meter per second square. The force applied on a body is said to be 1 Newton if 1 kilogram of mass is accelerated by 1 meter per second square. The force is said to be 1 Newton if 1 kilogram of mass is accelerated by 1 meter per second square. Okay. So suppose we have a mass of 1 kg and the acceleration produced in that mass is 1 meter per second square. Then we must say that the force should be 1 Newton. I hope you understood this. So let us go further and discuss about third law of motion. So students, third law of motion is very easy. Third law of motion. So it's a very small statement, not a very bigger one as compared to second law of motion. So here is it. For every action there is equal and opposite reaction. For every action there is equal and opposite reaction. This is third law of motion. What is the meaning of this? Let us come to that. Have you observed, suppose you have a piece, you have a ball and you are just throwing the ball to the wall, and once it is coming back, it is coming with the same force which you have applied. Suppose you are providing a very greater force to the wall, to the ball. What will held out? Once it will get back, it will come with a very high velocity, with a very high force. Why this held out? Because you have applied a very greater force. So you will get it back the same amount of force. In the similar way, suppose you may notice it or you haven't done it till now. So you can observe. Suppose you try to push a wall. Once you will apply a greater force, the wall will also apply the force to you, and you will come, suppose you are trying to push the wall in forward direction. Once you will apply that force, you will come in backward direction. You will apply the force in forward direction and you will come back in the by the similar amount of force in backward direction. Ball example I have given. If you will provide a greater force you will get back. So this is what it was observed by Newton, and he said for every action there is equal and opposite reaction. So suppose you apply F1 force and F2 force, this is active force which you have provided, and you are getting the force F2. So both will be equal, but sign will be negative. Why negative? Because force is a vector physical quantity. Magnitude will be equal, but direction will be opposite. So action force and reaction force will be equal by magnitude, but opposite by direction. So this is third law of motion. For every action there is equal and opposite reaction. Now students, after this topic we are going to study law of conservation of momentum. Law of conservation of momentum. So it is a little lengthy topic. We will try to cover it. I just want to increase the view of the board, so I am just pulling it in little backward. I hope now you are able to see the broad view of this particular board. Now, because this topic is lengthy, it was the demand of this topic. So students, we are going to study law of conservation of momentum. Law of conservation of momentum. Law of conservation of momentum. Maybe you are already familiar with this word, conservation. Conservation word might be you have heard. The meaning of conservation is to preserve something, to store something, or in Hindi we can say to give suraksha to an object. किसी object को सुरक्षित करना. That is known as conservation. So what is the meaning of law of conservation of momentum? The meaning is momentum will be conserved. And when it will be conserved, and which case we are discussing. So let us come to this case study and just observe it, and you will enjoy it for sure. So suppose we have a car. Suppose I am drawing a car. Actually my drawing is not as good as you are expecting, but I hope it is fine. So suppose we have a car and the mass of the car is m1 and the car is moving with a velocity u1. Suppose we have another car. Okay, another car. The mass of this car is m2. This is moving with initial velocity u2. Suppose this is the case before collision. Before collision means both the objects are going to collide. there will be a collision between these two objects. Okay, so before collision, one car is moving with velocity u1, another car is moving with velocity u2. Okay, mass m1 is moving with u1, m2 is moving with u2. Now let us consider that both the cars will collide. Collide means there will be a collapse between both the car, m1 moving with u1 and m2 moving with u2, both just collide with each other. As you can see, I have shown in the figure. So this is the case during collision. During collision, this is how both have collide. Now let us come to the third one. This is the first case, before collision. This is during collision. Now let us come to the third one, after collision. So what will held out after collision? So I have to draw it once again. Mass m1 and moving with, initially it was moving with u1 velocity, but the velocity of this object will change now. Suppose now it is moving with velocity v1. Okay, and the object means car which was moving with initial velocity u2, because after the collision the velocity will be changed. So suppose this m2 mass, now it is moving with velocity v2. So this is the case after collision. This is the third case, after collision. So this is how we have just indicated all the three cases. Two cars were there. Earlier one is moving with u1 velocity, u2, both collides, and after collision, because velocity will be changed. So suppose m1 car is now moving with velocity v1, m2 car is now moving with velocity v2. So I hope this is clear. We have to write it actually in physics once we are doing the derivations. So we have to do it with proper language. So I am going to mention all this case which I have told you now here on the board. Let us consider, we can write two objects as well. I have given the example of cars. Let us consider two objects of masses m1 and m2 moving with velocities u1 and u2 respectively. Initially these were moving with u1 and u2 velocity initially. Let both the objects collide with each other for time t. Due to that the velocity, suppose this object is object 1, this object is object 2, 1 2 1 2, so that the velocity of object 1, what is the velocity of object 1 now? Velocity of object 1 becomes, what is the velocity after collision? That is v1. So after collision the velocity of object 1 becomes v1 and velocity of object 2 becomes v2. So this is the simple case which we are discussing. Now students, what is the law of conservation of momentum? We haven't written the statement of law of conservation of momentum yet. So according to law of conservation of momentum, this is what I am going to write now. According to law of conservation of momentum, remember this statement, conservation. According to law of conservation of momentum, total momentum before collision will be equal to total momentum after collision. Momentum will be conserved. Doesn't matter that what is the momentum of first and what is the momentum of second, but total momentum before collision and total momentum after collision will remain equal. So what is the total momentum before collision? Firstly, try to understand it. So total momentum before collision, what is the amount of momentum before collision? This will be m1 u1. This is the momentum of first. Now what is the momentum of second? m2 u2. So total momentum before collision is m1 u1 plus m2 u2. This is the momentum of the system. One is having m1 u1, another one is having m2 u2. So total momentum is m1 u1 plus m2 u2. Should be equal to, this is what not I am saying, this is by law of conservation of momentum, should be equal to total momentum after collision. What will be the total momentum after collision? m1 v1 plus m2 v2. This is law of conservation of momentum is total momentum before collision and total momentum after collision are going to be equal. Is it clear? Statement should be clear. Now students, we are going to prove this. So let us come to the proof. So for proof, we need the space for proving it. So I am going to use, I will try to explain it here only. Now once, let us try to understand. When both the objects will collide, then first car will apply the force on the second car or not? Obviously, when both the objects will collide, then object 1 is going to apply a certain force on 2. Yes or no? So let us calculate the force applied by object 1 on object 2. Firstly, calculate the force applied by 1 on 2. We can write it as F12. 1 have applied on 2. One car is going, another is going, both collide. So 1 will apply a force on 2. I have written the source as 1, and who is facing the force? 2. So F12 is the force. Now how to calculate the force? Force applied by object 1 on 2. How to calculate the force? We already have studied in second law of motion. In this particular lecture we have studied. According to second law of motion, the force applied on an object is the product of mass and acceleration. The force applied on an object is the product of force and mass and acceleration. The force is the product of mass and acceleration. What is the mass? We are discussing about which mass? We are discussing first mass or second mass? Who have applied the force? 1. But who have faced the force? Second. So we always remember this thing. Suppose when we discuss about force, this object is having certain mass, I am applying an acceleration, I am providing an acceleration. So mass and acceleration I will consider of the body which is facing the force. So who is facing the force among 1 and 2? 2 is facing the force. We have to consider the mass of 2 and acceleration of 2. Clear? Force is product of mass and acceleration, but both the mass and the acceleration we will consider for the body which is facing the force. Among 1 and 2, which is facing the force? When 1 will apply the force on 2. So 2 will have the mass, 2's mass we will consider, and 2's acceleration we will consider. Is it clear? So F12 is equal to, mass of 2 is m2. What is the acceleration? How to calculate the acceleration? Change in velocity upon time taken. What is the change in velocity of object 2? Earlier it was moving with u2 velocity. Now it is moving with v2 velocity. So what is the change in change in velocity? v2 minus u2 divided by time taken. We already have considered that for t time, both for collide. So time taken is t. So this is the force applied by object 1 on object 2. Now what is the force applied by? Force applied by object 2 on 1, on object 1. Let us calculate this. F21. How much force is applied by object 2 on 1? Once both will collide, then this is not possible that only 1 will apply the force on 2. 2 will also apply a certain force on 1. Yes? So let us calculate this. By second law of motion, we can calculate this. So F21 is equal to, what is the mass of object 1? m1. What is the acceleration of object 1? Earlier it was moving with u1 velocity, now it is moving with v1 velocity. So what is the acceleration? v1 minus u1 upon what should be the time? Time will remain same, t. We will not write t1 and t2. Why? Because both the objects have collided for the same duration. This will apply the force on this, 1 will apply a force on 2, 2 will apply a force on 1 for the same time duration. For t time both have collided. So F21 is equal to m1 into v1 minus u1 upon t. So I hope this is clear. And comments are a lot required in physics. For example, we have mentioned force is the product of mass and acceleration. So we should mention this by second law. By second law of motion. Here as well, force is the product of mass and acceleration we have used. So we should mention it by comment. By second law. Otherwise your marks could be deducted out. By second law. Now we have studied one more law, that is third law of motion. What is third law of motion? Right now I have defined it to you. For every action there is equal and opposite reaction. So the force applied by object 1 on 2 should be equal to the force applied by 2 on 1. This is what we have studied today according to third law of motion. Is it clear? The force applied by 1 on 2 should be equal to force applied by 2 on 1. So F12 should be equal to F21. Now let us consider this. So let us substitute this there. I need the space actually, so I am just going to erase few part. I hope you have written the language. Now students, let us consider this. So F12 is equal to F21. F21 or minus F21, there will be negative as well. Equal and opposite reaction. Direction is opposite, so negative will be there. Substitute this value over there. So F12 should be equal to minus F21. What is the value of F12? F12 was calculated by us. This was m2 v2 minus u2 upon t. This was we have calculated. And what is the value of F21? m1 v1 minus u1 upon t. But negative sign will be there by third law of motion. Is it clear? Now t and t will be cancelled out, both are in denominator. Let us open this bracket. What will be there? m2 v2 minus m2 u2 is equal to, open this bracket, this will be minus m1 v1 minus minus plus m1 u1. Now do one thing smartly, as we need u1 u2 should be assembled one place and v1 v2 should be assembled second place. So what will be the case? m1 u1 plus m2 u2 minus m2 u2 will be shifted here, will become plus m2 u2 is equal to minus m1 v1 will be shifted there, will become plus m1 v1 plus m2 v2. So this is what we needed to prove, that total momentum before collision we have calculated m1 u1 plus m2 u2, and that is equal to total momentum after collision. So this is known as law of conservation of momentum. How we can say the momentum is conserved? Even the cars were collide, the velocity separately are changed, but the total momentum of the system is remaining unchanged. There is no loss in the momentum. This is what law of conservation of momentum is. I hope you understood this topic and you understood all the topics which we have discussed on today. So rest the numericals we will discuss on the upcoming videos. So thank you. God bless you.